Technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main.
So, welcome to another lesson with the Computer Science Bootcamp 2023 edition. This is day 2. Okay, so day 1, what we talked about really just, how to navigate this notion, which is where all our information is at. We just talked about really a lot of day 1 things, really things to just get your mindset together while you're going through this boot camp, which is, these little how to win in life, these 8 simple tips right here. Where to get the Zoom link. The Zoom link is right here. So every day we're going to click on this Zoom link so we can talk to each other. Now, when we talk about every day, we talk about the schedule. The schedule is going to be posted right here, just so we're all aware, we're all on the same page. I know we all have lives outside of this, and we can get confused, and we cannot, we probably won't remember. No worries. I have the status. I'm going to update it after every class. So current status is Monday through Friday schedule at 7 p.m. Central Time. All right. Saturdays and Sundays are free days. Let me put that here. Saturday and Sunday are Discord study days. Okay. Meaning that when your time allotted, when you have that 1, 2 hour, 3 hour time so you're able to actually get deep in your studies on Saturday and Sunday, then you just come into the Discord, make sure you're available. We'll be in the voice chat. We'll just sit here and just listen to, lo-fi in the background, and we'll just study. And if you have any questions, comments, concerns about anything that you're studying or want to study or whatever the case is, you can just unmute yourself and say, hey, I need help with this, right? It's just a good way for us to have like a study session or a study hall all together, but virtually. Okay. Current status, phase 1, week 1. So yesterday we talked about the phases. This phase, we are in finding your niche phase, okay? And we're going to talk about how computers talk to each other. All right. So what that is, that gives us a little understanding of the foundation of computers, so we can go on and be in any of these IT departments because we know how computers talk. Okay. It's also will help my CCNA folks. My CCNA folks, you definitely need to know the foundation so you can go in and start learning the exam topics and you don't get too confused. All right. Now, yesterday, like I said, day 1, we just talked about day 1 things. Your activity was to find your life path number. Let's just click on it really quick. Okay, your activity was to find your life path number so you can learn what your career path could be. And then once you find your life path number, your homework was to actually tag us on social media or on our blog post and let us know what your life path number is and what career you're thinking about being in. Okay. Now let's actually get into the meat and potatoes of week 1, the meat and potatoes of this boot camp, right? But week 1, let's get into it. So week 1 is all about computer network. It's how do computers talk to each other, all right? Now, before we even go deep, I want to, open up the floor. Does anyone have any questions, comments, concerns about anything from yesterday or what I just went over or whatever? I just want to open the floor really quick because I want to, again, give breaks to those who have questions in real time. No? Good. I take the silence as that. Cool. Now, I have this nice little diagram here. It's called packet traveling. So in order for one computer to send a message to another computer, it must be part of a network, and a computer network to be specific. So as you can see here, these computers are part of network A. This is a part of network B. This is network C. And then here's network D. And then it looks, if you can see this diagram here, you'll see that A is sending a message all the way through these networks till it gets to computer B, which is on a totally different network. All right. So that's essentially what we're going to be going over in a high level. How is this computer A sending hello, an email, a chat message, whatever type of message to computer B? All right. So I want you guys to put into your head as we go through this week 1 is you're learning how to send a email from your computer, let's say, to my computer, or from your computer to your grandma, or you're learning how to make a call. You're learning how that call traverses through the network from your phone to the 1-800 number, right? We're just trying to connect to someone else that is not ourselves. And how does that happen? And again, we have to break it down into, computer language. So the first things first is, what actually is a computer network? Because you're probably like, okay, well, computers talk to each other, and they talk from one network to another. And the only way they can talk is actually get on their own network. So the only way that A can send anything to B is if it actually connects to a network. And now we're going to talk about what even is a network, right? And how to even, well, we'll talk how to connect to it later, but what even is a network and what's involved in a network and what's all this good jazz? All right, so let's get into it. We have our, what we got? We have our what is a network, which I may update, but whatever. What is a network? Now, a network is a collection of devices that can communicate with each other, right? So when you say a computer network, is literally your computer with your phone, your tablet, your probably smart TV, your router or Wi-Fi modem, and a bunch of other things. But when we look at it as like a residential, like me and you are on our computer right now, you probably have your Wi-Fi box somewhere not too far, maybe in another room or maybe in the room that you're in, so your computer, or let's just say you're on your phone, watching this Zoom. So you're on your phone or you're on your computer, which probably is wireless right now because that's kind of the age that we're in. You're not really connected with any wires, but you are connected to your Wi-Fi network, right? So that's how you're able to even get on the internet, to even be on this broadcast right now, or even watch the replay. You need internet. You need to have an access, to your Wi-Fi. Your Wi-Fi gives you that access to, watch this video or watch this live stream. So a network, again, is just a collection of devices together. And that collection is really going to involve a computer and like a modem, a router, a Wi-Fi modem, however you want to say it. But it's usually those two things. But again, we're in the day and age of technology. So we have, smartphones and tablets and smart TVs and all these other things that connect in our network as well. Now we're going into pieces of our network. These pieces, like we already said, is a computer and you're probably your router. Now, when we're talking about network as being like a network engineer or even a cloud engineer or a systems engineer, those are system admins. You can even think of it like that. We are working on an enterprise network, not a home network. We don't need network engineers to help us connect this laptop computer that we're at now to our Wi-Fi. We need network engineers to help companies connect their networks together because they have thousands of computers. So therefore they'll have hundreds or maybe even thousands of routers, just depending on how big the company is, the enterprise is. So in a more like small, probably in a medium-sized to large company, let's say you work for T-Mobile, or let's say you work for Facebook, or we can name any big company, but let's say you work for that company on their network side. You would be dealing with the computers, of course, because we need the computers, right? They're going to give it to us as we work. That computer is going to connect to a switch. A switch, we'll talk about that more later, but a switch definitely is something that will help us switch our data while we're in the same network, okay? We also have a file server. A server is literally a computer that serves information. So you would think of a server like AWS, where you want to get, let's say you're at work and you want to get the payroll information. You wanted to take a look and see, the pay dates that they have or whatever file that's proprietary to the company. How would you, where would that document be stored? It would be stored somewhere on their server, right? Or if you just want to get files, period, it'll be stored on the company server. So you would literally ask the server to serve you some information. We'll get more into these devices as we continue on, but I at least want to get these keywords in your head so you can know exactly what it looks like, because these are like the icons from Cisco. These are the official icons of a computer, a file server, a switch, and a router. A router routes traffic. A switch traffic. What's the difference? A switch is literally, I'm just switching traffic. I'm just switching it from A, B, A, B. and it only deals with something that's in the network. But if you want to talk outside the network, AKA to another network, AKA to the internet, you would need a router. Us again, we're residential. We don't need a switch. We just need a router. Our computer connects to our Wi-Fi router, Wi-Fi modem, whatever you want to call it, and it goes right out to the internet. Okay, so we can talk to other folks. Right here is a hub. A hub is a switch in the sense, but a switch has more intelligence. So a hub is like something that switches the data around, the traffic around, but it doesn't have any intelligence. Again, we'll talk a lot more about these devices, but at least you have an understanding, right? Now, these are the pieces of a network. Oh, also the one that says media, this media or WAN link, that is cables. Those are actual physical, like Ethernet cables, fiber optic cables. So you probably, if you're the one in your household that gets Wi-Fi turned on, or, whatever the case may be, you manage your internet for the household, you'll probably hear them say fiber optic, connections. So that means like it's the fast of the fast. Like they'll try to, sell you on the connection speed, and it could be just regular old Ethernet or fiber optics. We'll get in that as we get a little more into this lesson. So we know the pieces of a network. This all makes up a network: a computer, a router, and some other equipment. Now, what applications use this network? Now, the network, again, is just a collection of computers together that's communicating with each other. So back in the day, when computers were big and clunky and were, cost thousands of dollars to even have one, right? What we would use is a regular white blackboard, and it would just, almost like matrix stuff, like, oh, you're a coder or something. But as technology advances, we get these pretty applications. We get these pretty user faces, and these user faces come in many different forms. So some of the forms are here, like Gmail, right? So this is an application. As we know, Google Gmail, it uses the network to send emails. So now we don't even have to send handwritten letters to our mom or to our family or friends anymore. We can literally pull up our computer and send an email at that. We also have things like multi-messages or text messages or iMessage, right? Again, these are on our applications on our phone. So we don't have to send emails. We can literally send instant chat messages from however we want to use it, however we want to send it, should I say. Another example is we have our social media platforms. These applications use the network. They need the network for us to mingle with each other. Facebook, Instagram, LinkedIn, these are things that connects us to the world, connects us to the internet, to people who are not in our household, people who are not in our city, people who are not in our state, who are not in our country, who's not in our continent, right? These are applications, again, that use a network in order for us to do what we want to do, which is Facebook, well, at least these are all social media. This is email. This is, instant chat. And as technology is growing even more, we're having things that connect to internet that we didn't think. Like when you think of the Internet of Things, you probably hear IoT. You probably see IoT. That's the Internet of Things. What does that mean? That means that things connect to the internet, like Alexa. There's so many things. We got the iRobot little vacuum thingy. We have our refrigerators now that connect to the internet. Like so many things connect to the network. And that's why we call it the Internet of Things, IoT. And Alexa is part of that category. So when you think of that, think of all the other things in your household that connects to the internet. That's usually, we don't think of it. We don't think of it too much as like, oh, it's techie. We just, we expect it to connect to our Wi-Fi to work. But that's some real futuristic stuff, right? To have an Alexa, to have your refrigerator, connect to the internet and show you, your emails or talk back to you. Even your television, like that is, smart TVs are like, very futuristic, believe it or not, again, it's using our network. That's it. Moving on, considerations for a network. So, again, we're talking from an engineer perspective. Okay, so from an engineer perspective, we are troubleshooting the network. So now some of us can go really deep in our knowledge and actually architect this network. We can say, hey, we're going to make traffic flow from this end. We're going to add these protocols. You can be very deep into it, or just from an engineer perspective, we want to troubleshoot it. We want to monitor it. We want to manage it. So some of these things we want to keep into our mind when we're in that frame is speed, delay, and availability. Now, speed is the speed of the network. You, again, if you are the one to, manage the network in your household, your Wi-Fi, you probably call your Wi-Fi provider up. You're probably the one to set up the service or disconnect or pay the bill, whatever the case may be. You are concerned about speed, especially if you work from home. You're like, okay, does my Wi-Fi give me enough speed? Is it fast? Download fast? Can I download, movies, videos, or files faster, or upload them fast? Whatever the case may be, I should not have to lag. My internet should just be seconds to where I get to a website. That's where the speed comes in. Delay, kind of the same category as speed, but again, we do not want to have any delays in how we use our internet. If we are watching Netflix, we don't want that red Netflix circle to be like, oh, it's loading, because our internet has delay issues. So again, we are looking at these considerations because we do all these things. We want to watch our Netflix totally fine without it loading up, that death little circle. We also want to check our emails and do our work on our computer because we work at home. So we don't want anything to slow while we're trying to go to the next page, or it's downloading a file and it's taking forever. And also availability. We want to, and it kind of encompasses speed and delay. Availability is making sure that our network is always available. Imagine if you were a network. Let's just keep it. You're right here. You're right now. And let's just say that your internet goes out. And it goes out because that's just happened sometimes. Your service provider, let's say you get internet from Xfinity or Comcast, so they're just cut off on you, and some days, sometimes out the day, their server gets so overloaded that, the internet just stops. And then you just have to wait until it comes back on. When it first happened to you, if you're probably watching Netflix, you'll probably be a little, inconvenienced, but imagine if you work from home, and imagine if it happened every day at 2:00 during your meeting with your boss or something, or just imagine you were really troubleshooting with somebody and it just keeps going out. You're probably going to think, I need a new internet service provider. I forget Comcast, forget Xfinity. I'm going to go to T-Mobile or AT&T or somebody else that's around, because you want your network to always be available when you need it. So availability is good on just your residential side and also on a big grand enterprise side. These are three things that, you have to keep in mind, regardless of the type of network and regardless of how, small or large the network is. These are very, very important. And you know that now, especially with this remote working, we know that these things are just, we cannot live without it. Even if you was like on TikTok, just scrolling, mindlessly just scrolling, imagine that thing just went out. If it went out on your Wi-Fi, you would take Wi-Fi off and go to what? Your 5G. But imagine 5G not working either. Imagine your phone just not working just because, you would be highly upset and you would want to get a new phone. So how do you think that, users feel when they're using the computer and it's not working? You as a network engineer, cloud engineer, system engineer, whatever, or even administrator, you have to troubleshoot these things. So you have to be aware of these things, okay? Let's talk about network design, okay? Now, these designs can be physical and logical. We know what physical is. Physical is what you can actually touch it. You can actually see it. It is there in real time in its physical sense, okay? Logical, it's only in the mind. Right? It is not, you cannot touch it. It is not tangible. It is what we thinketh, right? So a network design, how we design a network, can be physical and logical. Well, it should be both. It should not just have one or the other, all right? Now, let's go into these network designs. These are just some of them. So I don't want to get too deep in. That's more on a CCNA, network engineering ground. And we're not all here to be network engineers. We're all here to learn the basics of computers. So network design. Network design is just like, designing a city, designing a neighborhood. If you were to buy a plot of land, let's say you're to buy like 40 acres, and you're tasked with, we're gonna create a subdivision, or we're not even gonna think that big. Let's just say you bought a house and you're gonna renovate it. So you're gonna renovate it. Now you want to see how you're gonna design it. It's only one bathroom, so maybe you're gonna make 2 bathrooms now. So now you have to look at the blueprint of the house and see where you're going to put this other bathroom. Maybe you want the master bedroom bigger, or maybe you want a driveway because there's no driveway. I don't know, but you're designing it. It's the same, instance when you're thinking of network design. How are we designing this? How is this network design? Both physical and logical. So let's talk about it. We have bus, which is the original design. This is how the design started. Of course, it got more advanced as technology got advanced, but bus is the OG. What is bus? Think of it just like a bus. A bus goes right down the street, right up the street. Okay, that's their line. And that's exactly how it is. And this is physical and logical in a sense. The physical, back in the day, they had a really long fat Ethernet cable, and every computer would literally clamp onto that cable. And that cable would provide the ones and zeros of network service. And the computer that's clamped onto that cable would do such that. Right now, we don't have this big, large cable. We have our Ethernet cables. You'll probably have, like your router at one end, and then just a long or a multiple Ethernet cables, or even a splitter where you put Ethernet cables in each one of these computers. All right. So it's just literally a long line of computers. Then we have something like a star, right? It's more in the middle, a central hub of getting network service, and every computer connects to it, right? So you probably have a star right now as your network design. You have your Wi-Fi box probably in somewhere in your house, and every device connects to that one Wi-Fi box. That's usually a star. It's a star logical for sure, but is it a star physical? Maybe not. You probably actually have your Ethernet cable connected to your Wi-Fi box, which would be in a bus type of design. Okay. Excuse me. We also have other designs like a ring, where everyone's connected to everyone in a sense of a circle. We have a mesh. Mesh is just, connected, interconnected. Everyone's connected with each other. We have a tree. A tree is usually like a root device, is usually that head honcho, and everything else branches off of that root device. Excuse me. Then we have point to point, more on a internet type a technology. We'll get into it, but point to point is almost like a bus, right? It's literally a straight line, but instead is, to each point. These are just some of the designs, and we call this topologies. And I don't want to get too deep into it because it's for CCNA folks, but at least you understand that networks have different designs, and those designs can be physical and or logical. Okay. Going into the physical aspect of this network design, they are literally the computers are being connected via cables. That's how we're able to physically have a design of a bus or a star or a ring or a mesh. Like, how do we physically connect these devices? With cables. And there's only 2 types of cables that we have. We have fiber and we have Ethernet. Fiber, Ethernet, I guess we can go with fiber. Fiber transmit ones and zeros through light. Okay, literally takes light, like you see the light, right? Literally takes light, and within that light is literal ones and zeros. It is the data. It is your email, right? You say, hey, grandma, how are you doing today? In your email, let's say you put it in a text message because we're in 2023, we text our grandmas now. So you text your grandma, hey, grandma, how you doing? And those ones and zeros are being sent through light. Yeah, it is. And then we have Ethernet. Ethernet is sending those same ones and zeros through your email, through your text message, but it's through electricity. Okay, that's the OG of it all. Because we talked about, I don't know if it was in this class, but if you guys were kind of more going through some of my YouTube videos, we talked about how Ethernet came about with the telegraph, right? And telegraph is synonymous to the Morse code. So what is Morse code? You're literally, sending pulses in a code to make A, B, to make, spell out something. Those pulses are electrical pulses. So when you hear deep, 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 that's electrical pulses being sent in a pattern. So now you can understand, okay, so beep, 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 beep means A. Beep, 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 beep means B, right? So you're writing it down, you're understanding. That is the original way of Ethernet communication, right? Electricity communication. And then it gets bottled up into, these cables, because you probably have an Ethernet cable right now. You can take that cable, if you don't mind, you can just cut that baby open or take the head off, this little clear RJ45 is what we call it. You can take that off and you can see all the wires, all the electrical wires. It's about, 8 of them. So if you go down, this is exactly what you is, 8 of them. So you exactly see here the actual copper cables, the copper wires, I should say. These wires together make up how the data is going to be sent. These wires also tell you what devices you can connect to what device. Now, we're not going to go in onto Ethernet cables. It's all, explained in my CCNA course. We even make Ethernet cables in the CCNA course. So if you're interested in all of that, please go over there. I'll send the link out, and I'll put the link more in the Notion so you don't have to keep referencing the Discord. You could just stay in the Notion and see it. But regardless, Ethernet cables is the OG of sending data, right? Fiber optics, fiber right here is through light, and that's the new thing. That's more faster. Why would we use one or the other? Ethernet is more home-based. So right now, you're probably using the Ethernet cable or have an Ethernet cable on standby. Fiber is more for enterprises. So for your Wi-Fi box, it's connected into the wall jack of the wall. Inside that wall is probably a bunch of fiber optic cables going down into the wall, going into the ground, into probably the green box outside or to a telephone pole outside or something. It's going to a central hub. And inside of the ground are those cables, which are fiber cables. Sometimes they mix fiber together. Fiber optics is fiber Ethernet. It's like Ethernet, pumped up. But again, unless that's, your job as far as a technician or a cable junkie, you really wouldn't need to know too much of the mechanics of these cables, okay? But just know we have copper and fiber. Ethernet is electricity. Fiber is through light, okay? It's a literal beam of light that can travel way further than electricity can, okay? There's a lot of science behind it, and you don't need to know that unless, you don't need to know the science unless you want to be an architect. You do not need to know the mechanics of how to configure these or use these unless you want to be an engineer, all right? So the fact that you just know that there's 2 different types gives you that foundational knowledge right there. All right, and again, we talked about the Ethernet wire, the wires in the Ethernet cable. No lie, you can literally take an Ethernet cable, take this little clear thing off, which is our RJ45 connector. You can see that right here. That's what it's called. And you will see the green and white cable, the green cable. You'll really see these colors. And these colors, again, help us determine how the data will be sent through that cable. All right. Now, let's talk about transmission modes in the network. What is transmission? When we talk about transmission modes, we're talking about sending data. How is it being traversed? How is it being sent? That transmission, how is it, working? How is it being sent? Now, it's 2 ways. We have a TCP and a UDP. TCP is transmission control protocol, and UDP is user datagram protocol. Check me on both of them. I'm not going to say I'm 100% right on the acronyms, but it's TCP and UDP, right? TCP means that it takes a handshake. So in order for me to send you something, I'm using a handshake way, meaning that I have to synchronize with you. You have to synchronize and acknowledge that we are going to talk back, And then I have to acknowledge back with you that I got your synchronization. We're good. So how I was explained to it, or at least how I could understand it, was think of it as two people and they're doing a three-way handshake. So the first person to say, hey, my name is John, how are you? And then the second person comes to say, oh, hey, John, my name is James, how are you? And then John comes back and say, oh, hey, James, yes, John, and whatever. It's a three-way handshake. It's you would think it's only two, but again, just know that it's three ways. Three ways, the best way, if you're on your CCNA way, is synchronize, acknowledge, and then acknowledge. The sender is synchronizing with the receiver. The receiver is synchronizing back with the sender, but acknowledging that, hey, I know you want to talk to me. We can talk. And then the sender is going to do one more, which is an acknowledge and say, okay, now we both agreed to talk to each other. Let's start talking to each other. Now with UDP, it's on a whole different ball game. It doesn't care about synchronizing. All it's going to do is literally just send you information. So the sender is going to say, hey, I would like some coffee. And then the receiver is just going to continue just sending coffee. Doesn't matter if you paid. It doesn't matter if you are a guest. It doesn't matter. You said you want coffee, so here's coffee. I'm not going to do any checks and balances. I don't care to synchronize with you. I'm just going to give you the information. So in real life, to make it a little more understandable, TCP is like when you get a phone call to your number. If I was to actually call you, that's more of a TCP type of transmission. But if I was to call, let's say for UDP, if I was to make a call and the call was broadcasted over your full intercom section or your full house or the full department or in the full company building, that's UDP. UDP is like a broadcast. We're just here just to send out the information. We don't care if it's you that get it, somebody else that get it. We just want to get it out of here because someone requested it. But TCP is like, no, we're actually going to send it to the person that needs to be sent to. We're not going to blast all this information out. We're going to check and do some balances and make sure you are the receiver, because I have something to tell only the receiver. UDP says, I don't care. Somebody said they wanted it. Here you go. Okay. So again, think of UDP as broadcast. Think of more TCP as, one-to-one delicate care. There was a meme on Facebook or something where they had TCP and UDP. And side note, you guys should follow like tech memes or tech Facebook groups so you can kind of get immersed in the world, I should say. But anyway, so they had a meme. So they had one where it's TCP and they were, holding the baby real nice. And the mom gave the baby to the dad real nicely. And then UDP, they had the baby and they just threw the baby across the street. And it's like, that's UDP. So just to think of it like that way, like UDP doesn't care. It's just going to send it. It's just going to throw that baby out the window. But TCP is going to hand the baby to the next person out the window. Like, no, don't drop this precious jewel. But UDP doesn't care. It's very important to understand these transmission modes, because regardless of where you're at, software developer, project manager, doesn't matter what you choose to do, you will always end up dealing with some type of TCP or UDP, type of issue or something in your troubleshooting step. And if you do not understand these acronyms, then you don't know what you're looking at. You wouldn't know how to really troubleshoot your issue or resolve your issue at a quicker pace, because you're not understanding that, this needs an actual synchronization and the sync is not happening. So that's why we're getting a TCP error, or that's why you're getting some type of error, right? Or even you're trying to figure out why is everything broadcasting? Well, why is it not going to one person, and acknowledging that, oh, well, maybe it's in a different mode. Again, you'll see this more and more as we continue, but at least you have these acronyms to know. Now, addresses in a network. Just like you send any old letter, we send any old email or text message, we have to have an address from, and we have to have an address to. So what is your address and what's the receiver's address? We need those, or your data is not going to get sent anyway. Your email's not going to get sent. Nothing is going to send to anyone if you do not have these addresses. So again, just think of it of a letter. If you have a letter, you writing it, you're old school, you're writing, let's say you're writing a credit dispute letter. You're like, hey, take this off my credit, it ain't mine. And you put it, in an envelope, and you take it to the post office. You're going to have to put the credit bureau's address on that letter, as well as your address as well. So same thing applies in a computer network. You need the address. And there's two addresses. We have a MAC address and an IP address. A MAC address is the physical computer. This does not change, and this is unique for every last computer device. And when I say a computing device or a computer device, that's not only just your laptop or your desktop, that's also your phone, your tablet, your printer, Alexa, your refrigerator, Roku, anything that you have to connect to your Wi-Fi has a MAC address, okay? This MAC address is 48 bits. Bits are the ones and zeros. So each 1 and 0 is a bit, okay? So when you're probably watching Matrix, or you're probably watching some hacker movie, and you see like a whole bunch of 1s and 0s, those are nothing but bits. Now, 8 1s and 0s put together equals a byte. So now you're thinking about kilobytes, megabytes, gigabytes, right? We'll get into that later. I'm not going to give y'all too much crazy math. But when we say bits, it's literally the 1s and 0s. So a MAC address makes up 48 1s and 0s, okay? This MAC address works on an OSI layer 2. We'll talk about OSI layer later, but MAC addresses are only deal with computers, and computers, again, your phone is a computer. Anything that connects to the Wi-Fi, you can say is a computer. So everyone has it. It is a physical address. It is unique to every single device in the world, okay? This MAC address is assigned by the company that makes that computer, the manufacturer. So your phone, your iPhone, it has a MAC address. That MAC address came from Apple. Your computer, probably your computer's a ThinkPad or an HP. That MAC address came from HP or ThinkPad. So if you ever have issues with it, ThinkPad, HP, Apple, Android, Samsung, they can pull it up and say, okay, this is one of our devices. Let me either help you troubleshoot it, replace it through warranty. I don't know what all you need from it, but just know that your device has a MAC address, okay? Physical address of the computer. Now you have another address, which is called your IP address. IP stands for Internet Protocol. So it is your Internet Protocol address. It is your address that you use on the internet. Now, we have a couple different addresses we can use. We have a private internet address and a public internet address. Why do we have both of those? Well, we have to have both of those because just like a MAC address, every single device has its own unique MAC address. And back in the day when the internet started, every device had its own IP address. But everything now is so many devices. Outside of computers, what do we have? We have freaking iRobot that mops the floor that needs an IP address to connect to the Wi-Fi. Again, our Alexa, we have our Roku, we have our printer, all these things that need IP addresses to access the network. So with all these devices, and it's billions of us in this world, we do not have enough IP addresses for everyone to have a unique one at all times. We just don't, okay? Now, we kind of do now. It's called IPv4, but we're not going to get, deep into IP addresses. But just know that we do not have enough for every single device to have their own IP address, okay? So we cannot treat IP addresses like MAC addresses. So what's the fix for that? Since every device cannot have its own IP address, because there's so many different devices out here, so many people, you probably have 5 devices on your own. So how do we mitigate that? What we do is we have private and public. So private means that you are only in your own network. Your own network means your own household. Let's just look at it that way. Your own house is a private network. When you leave your house, it becomes public. So in my own home, my address can be, again, a public address. a private address. That private address means that it's the same, like let's say my address is this right here, 150.60.122.98. Let's say that's my IP address, my private IP address. My neighbor who, let's say I live in an apartment building, my neighbor who's right there across, the hall from me or right under me probably can have this same address, but only as their private address because they're only talking to the folks in their house. But once they decide to get out into the world, because I want to go out into the world, like we're both, joined the computer science bootcamp, so we're both trying to go out to the world and get on Zoom, our private IP address now change to a public internet facing IP address. And it could be something totally different than this, right? But it has to be different. We're going to have two different addresses because now we're in the same realm, which is the internet. We're in the same household. That household is internet. So since we're using the same cloud, the same house, we now have to have two different ways to identify each other. But when we go home, we could literally be the same number. And that's just because we do not have enough IP addresses for everyone to have their own at all times. If you are interested to learn more about that, we can go deep into CCNA. I don't want to get you guys too caught up in addresses because that's a whole bunch in itself. But just know that an IP address is your internet address. Your MAC address is your computer address. Your internet address is 32 bits, so it's 32 ones and zeros, unlike your MAC, which is 48 ones and zeros. Excuse me. Your IP address is a logical address. It does not say where you're physically at. It says where you're logically at, okay? And it can change depending on your environment. So your IP address can change if you work from home. And let's say on Tuesdays, you go to the office. Then you have a whole nother IP address that you would use in the office and when you leave it from, being on the internet. Or maybe you go and visit your family out in Minnesota. You'll have a whole nother IP address as well, right? Your IP address is going to constantly change, all right? Now, when people say, you got hacked or something to where they're able to probably go into your computer and turn your webcam on and see you, or, just these things of making sure we protect ourselves, and why we even use a VPN, a virtual private network, because these addresses here can be taken advantage of. So if someone finds out our IP address, then they find out what network we're on. And they find out what network we're on, they can do even more to find out our physical address, which is where's our computer is located. So that's when folks can say, you've been trolling me on the internet, but you forgot that I'm techie. And now I just gave the whole internet your physical location, where you're at. You're at a Marriott hotel down in Houston, Texas. And it's like, how did that person know? Oh, because we found your IP address, so we found what network you on, and we pinned that network to your physical location and we found your MAC address. So your MAC address is the one that's sending me trolling messages on Facebook because I was able to do a trace on your addresses and it pinned back to you. So now I just gave it to the world and you're about to get harassed. So it's good to, one, really get on VPN all the time because you do not want you to be subject to any type of security breaches, right? And it's too good for you to understand this because what if you need to teach someone a lesson? Not saying that that's good, but what if you just need to do something to where you need extra, tech knowledge on addresses to get to where you need to get to? So for us in network engineering, how do we use this? Somebody's probably like, hey, a router went down or a switch went down or a Wi-Fi hub went down or my computer won't come up or whatever the case may be. We can literally look at your IP address, find what network you're on, and then find what MAC addresses are on that network and probably pinpoint which one is not working and which one is you. A lot of times, I've always worked from home. So if someone is just having issues with their computer, with their network, they're just having tech issues. And obviously I'm at home and I'm not going to come into the office to help them, or I'm probably not even in the same state, then I literally remote into their computer. So I need their IP address and I need their MAC address. They need to willingly give that to me, or I can go hunt and find it, which would be a lot on me because they can just literally go on their computer and get the information. But regardless, I just need these two and I can get into their computer and start navigating and do whatever I want with it. And again, their computer is a company computer, so that's why I will have more rights to it. But regardless, you need to know addresses in a network so you can understand the differences and know how to protect yourself as well. Okay. Now, lastly, let's talk about virtualization in a network. Okay. You probably hear virtualization all the time. It's synonymous to cloud. So what is virtualization and why do we want to virtualize our network? So virtualization is literally making a virtual instance of something. It's making a non-physical replica of something. And most of the time it's just a computer. So as you can see here in this diagram, this is a regular computer, okay? Just a physical computer. Now, this physical computer, we can virtualize it and make it 5 different computers on its own. Why would we want to do that? So let's say that you started your company, and in your company, you wanted to have, a computer for your assistants, a computer for your tech people, a computer for your sales people, and your own computer, right? Because you don't want to share computers with everyone. You want every department to have its own computer, or every person to have its own computer. Right now, after so many, let's say you have like 5 people as assistant, 5 people as, management, you're just, you're ramping up with more employees. Then you're going to have to buy more computers, and computers are pretty expensive, especially ones that you want to make sure that are last long and have the speed and all this good jazz. So instead of literally buying a computer for every single person, you can buy one computer and you can virtualize each computer. So instead of, again, buying whole hardware, they can literally just log into a website and utilize computer resources. Okay? Virtualization is good to help us on our pockets, and it's to help us with space. When you think of a data center, when you hear the word data center, or hear the terms data center, you'll probably think of a room or a building of a whole bunch of computers, a whole bunch of servers or routers and stuff. Maybe you guys are into like blockchain or into like crypto, so that crypto mining, you over there in China, they have these big data centers where just whole big computers and such, right? So instead of spending so much money on all these computer devices, we can just use one computer and make 5 or 10 or however we want many instances of this computer. Okay, it's going to have the same CPU. Same CPU is the power, is the brain. It's going to have the same RAM. RAM is the memory. It's going to have the same disk and same hardware space, just as regular. Same input output. That's where I/O is. The same input output as a physical computer. There's no difference. The only difference is it's not physical. It's logical. And logical means that you need software to log into it. You cannot carry it around in your pocket. Okay. So it helps us. It helps us, again, with cutting down having a whole bunch of equipment, right? It's in the cloud. When we think about the cloud, you guys probably think about, I don't know what you think about, but you should be thinking about the cloud being someone else's computer. AWS, Azure, if I'm making a server, I'm not making a server. If I need a server, if I need Active Directory, if I need something in a sense to where I don't want it on my computer. For instance, Gmail. You don't really house mail on your computer. That's in an app that you go to, or a website that you go to, but that's not taking up space on your physical device. It's not taking up space on your phone, nor is it taking up space on your actual computer. But it is housed somewhere. When you go to Gmail and you're trying to find a mail that, you search, you're trying to find some receipts or something, it's all there, but it's not physically on your computer, on your phone. Where is it? It's in the cloud, AKA on someone else's computer, right? AKA that computer is virtualized. So it's millions of computers they have that is considered the cloud because it's all virtual. It's not even, I can't even touch it. You cannot touch your Gmail. You cannot physically touch the emails that you receive. Just like you cannot physically touch the text message that you receive. You cannot physically touch the picture in your phone. You can touch your phone, but you cannot pick up the picture as if it was a Polaroid or something, or as if you went to go get it printed out. That's all cloud-based. That's all virtual. Okay? Cloud equals virtual, virtual equals cloud, which equals a computer, someone else's computer. It's not your computer. It's not your hardware. It's another piece. It's a software. I don't want to get in and talk about hypervisors and different VMs. I would like to save that for you guys who actually want to be cloud engineers. I've definitely had a job as a cloud engineer, so I can give you a little bit of pointers. Well, I have a contract now that's, in cloud. So I can definitely give you guys some pointers. Cloud is the big thing. Cloud is where you want to be. Virtualization is where you want to be. Okay, whether it's Amazon, whether it's Microsoft, Google, doesn't matter. If you do not understand virtualization, even on foundation, you are not going to succeed in this ever-changing tech environment. Okay, everything is cloud-based. You know that. Everyone knows that. So let's learn it, right? So that was really it in our lesson. Let's just go back a little bit. I just wanted you guys to understand what a network is. And a network is just a collection of computers. That's our computing devices. That's all it is. All these devices connect to the internet. These different devices, it's so many, but just to name a few, we have a computer, we have a server, we have a router, we have a hub, a switch, and it's just to name a few, so many out here. We know that. Applications, so our software developers, our software engineers, our development team, they're going to create pretty applications so we can use our network in a more user-friendly way, right? We can use it in a more integrated way. And we came from Gmail, we came from social media, and now we have Internet of Things. Now we have the things that uses our network, things that didn't use it before outside of a computer. Alexa is one, right? In our network, we're always thinking about how fast our network speed is, and are we going to have any delays, and is our network always going to be available for us to connect to, or do I have to wait until after 3 p.m. to get on the internet? Like, availability is number one. Okay, we talked about different designs of a network. There's so many different designs. These are just some of them. Well, these are like the main ones you'll see out here. But why do we care about designs? Because, we want to understand how data flows in the network, how the cables are connected. And speaking of cables, these are the two types of cables that connect our devices so we can even talk to each other. Because again, the network, all these have to be connected to each other. There's no way you're going to just have a computer that's not connected to anything and you think you're going to get on the internet and talk to anybody outside of yourself. That's just impossible. So when people say, oh, I'm going to live off grid, if you do not have a telephone pole to connect your computer to, you will not talk to the world. You're going to be off grid and you're going to be by yourself. There is no 911. There is no get on Facebook and show everybody that how you live as off grid. None of that's possible. You need a connection you need to connect to another device that connects to another device. That's called the internet. The internet is all of us connected together. Once you unplug yourself, you're not part of the internet. Okay, I just want to really make sure y'all understand, because I heard somebody say, no, you can be off grid and remote and, you could just hop into the internet, hack into the internet. And it's like, I don't know what movie you watched, but that is not real life. And take it from a person who manages the internet. Okay, applications, we use those applications, considerations. Oh, cables, Ethernet fiber. One transmits ones and zeros, our data in a electricity way. The other one does it in a light way, a literal beam of light. Okay, light travels further than electricity. Okay, FYI. Transmission, we talked about TCP, UDP. TCP is literally being careful with the data. Hey, is this your email? Whose email is this? Oh, are you sure this is your name? Okay, well, here's your email. But UDP is like, oh, email, let me just send it on now. Everybody gets this work. Here, it doesn't matter. I don't care about your name. I don't care to shake your hand. Here's the information. Hopefully you got it. Don't care if you got it or not, but I sent it. That's UDP. And then our different addresses, okay? We have, our address. We have our address all the way down to our apartment number. So you got our city, state, street address, and apartment number. okay, to send information. And we need the same information to go to who we want to send it to. We need the same thing in the network. We have our MAC address, our physical, where we're physically located. We are physically in Atlanta, Georgia. We're physically in Minnesota. But our IP address shows that, oh, no, we are in this network. We're on the East Coast network. We're on the Texas network, but you don't know that I'm actually in Houston, or you don't know that I'm actually on, Westheimers Road, like I'm actually, this is my physical address, which is my MAC. IP is logical. It's where a roundabout. So when you get on VPN, that's your IP address. That's your roundabout area. So you probably chose Japan. You probably chose Switzerland, to be your IP address, your logical address. Change the environment. And then we virtualize our network. We virtualize our network because we need more instances. We don't need just one computer. We want 50 computers. And we don't have the budget to go buy 50 computers. So we're going to take about 2 computers and make them in virtual instance. One computer has 25 that it virtualized into. The other one has the other 25. Now we have our 50 computers that we can use in our network to do whatever we want to do. So we could literally assign each computer to do, one task. So now we have 50 tasks. But that helped us, because all we was going to have to pay for, $2,500 per computer, or we can just, pay $100 and get 50 virtual computers, right? They use the same way. It's still fast, still has the same operating system, same processing unit, same amount of memory. It's just virtual. It's the cloud. Now, homework. This was really from my last boot camp. So let's go back to Notion. For your homework, I really want you guys to learn the basics of Linux. Why? Linux is everywhere. Linux, you cannot get away from it. If you're going to be in tech, you're going to use Linux to some degree. You may not know up front that it's Linux, but the back end, that's how it's working. Okay? Everything uses Linux. Linux is literally just, a black screen and the letters. So if you're into like the matrix or, coding, you see how the coders be with a black screen and those green ones and zeros. That's Linux. Okay. It's just a terminal and, you literally do whatever you want to do with it. Right. But us as folks who like things to be pretty, things to be user friendly, we have applications like Zoom, OneNote. This is a Brave browser, Google Chrome, Excel. We have all these different applications that make it user friendly for us. And, we're able to see it and use it better because it's good for our eyes. And, it's just pretty colors and we can click stuff and, see how we can click and do all this stuff. That's so great. But the bare bones of this is Linux. The bare bones is just a terminal and we just, press our keys back and forth and do the same exact thing. You can get on the internet with Linux. You don't have to have this pretty browser and type in technicallyspeaking.com. Like you don't have to do all that. So I think it's great for you guys to learn at least the basics of what Linux is. So no matter what, how to tackle really almost any technical issue when it comes to software, right? First thing, and this is all free, right? This is a great thing that I've learned, that I found helped me out when I was first started, and it'll help you as well. So getting started, it helps you the history, so you can get the history. Linux distribution, sometimes we talk about the Linux kernel. I was telling you guys about that, and some of you probably was like, what are you talking about? So here you can actually read up on it and actually get spun up, all these things, all these different distributions are good to understand. And this is just, something I want you to go over. Get acclimated to what Linux is. It's just having just Linux knowledge just on a foundational level on your resume gets you into a lot of places, right? And just learning how to work your terminal just really helps you no matter what. My wheelhouse is network engineering, but no matter what, I am still dealing with, programming. I'm still dealing with, automation. I still have to have those skill sets to not only keep my job, but to stay relevant in the market. So you guys are just starting off. might as well start where everyone else needs to start anyway. Some people are probably already 20, 30 years into their career and they don't even know Linux. And guess what? They're going to get replaced by someone like me who only has 3 years in the game. Why? Because I have new knowledge. I have knowledge that will innovate a company, add value to a company, instead of someone who's used to doing the same thing over and over again for the past 5, 10, 15 years. They need fresh blood. They need new people, So their computers, you say robots and AI, it's not going to take over our jobs. The young people are going to take over the jobs. So are you part of this young crowd or not? And not young in age, young in knowledge, So that is the homework for you guys, okay? Well, that's the activity. The homework is to actually, what did you learn with Linux? So you went through that. You don't have to go, let me see. You don't have to go through all of it because look how long it is, You can literally bounce around. Definitely to get started, command line. I would say, at least do these 4, if anything. But take a look around. Click on some other stuff, especially for my CCNA folks, like subnetting, network basics, literally click on things and learn, okay? That's your activity. Now your homework is, what did you learn with Linux? So same thing as you did with the numerology. Tag Technically Speaking on our social media. Click on these. The social media is right here. Or if you're not on social media or just don't want to be on social media, don't want to do that, just share it in the Discord, in the general Tech Talk channel. Say, hey, this is what I've learned with Linux. This is whatever you want to say, but tell us what you've learned with Linux. Linux is a great foundational skill to have. You can literally go anywhere with it, just on a foundation, on a basic, without getting any type of little cert or anything, just learning what you're learning in this activity. You can literally, hop right into a tech job, a good help desk job, or a good admin job, or an IT consulting job, or maybe a cloud admin, or, something just with this knowledge. You definitely are qualified to be in tech. Okay. In tech, making at least a good 60, 65. I would even go as far as 70K, right? Some of you guys, that's exactly where you want to be. That's still too low, right? We want to strive for 80 to 90K salaries. But if you never even got up to 60, then, this probably would be something good to just learn Linux, on like really learn it, and then put it on your resume and go get a 60K job. Those are they're out here. Those are low ball tech jobs. Those are really, so if you need that, we can get into that, no problem, just after doing this activity, right? So that was really it that I had for you guys. I'm going to chop this up, obviously, put it in this lesson section. You already have the activity. Just click, and then go ahead and do your homework. I am checking the homework, you guys. So I know you're probably thinking like, oh, whatever, but I am seeing who is actually tagging us on our social media or who's actually posting it in the alternative ways. So we have about, I would say 30 active students, 40 probably in total. I still need about 40 replies. I need from tagging and what you're saying in Discord, that should equal up to 40. Now, it's not like if you don't do the homework, you don't pass or anything. It's really up to you to do it or not. If that's your integrity. However, it's good to do it so you have the work behind it. Okay, this is building your portfolio as well. So when we get to resume revamp, you should have, oh, I know Linux, I know what that is. I can talk to it in an interview. Oh, I have this and that. It's just, we just go on. Your portfolio should just be huge after these 2 weeks, honestly. I see a comment. Please clarify, where do we find the homework assignments? Homework assignments are always for week 1, because we just started, it's going to be right here in Notion under week 1. But yesterday, we had day 1. So we go into our Notion. I gave you guys the link. Here you are. You just literally scroll down. We are in phase 1. If you don't know where we're at, it's in this little box, current status, phase 1, week 1. So phase 1, you can click on day 1. Day 1 gives you homework, just, cool little homework for our activity. And for the rest of the week, all our homework, all our lessons will be posted in here under week 1. Okay. Everything is in Notion. Everything from homework to lessons to recordings to, extra stuff, which I wanted to show you as well really quick before we end this is in our Notion. I don't know if you guys have paid attention, but if you scroll all the way down past the phases, you will see other resources below. Okay, please utilize these resources. They're here to help you. Again, this bootcamp has encompassed all types of folks, people who are in cybersecurity, people who want to be network engineering, people who want to be software developers, tech writers, content creators, just help more in their business. So many different avenues, so many different people are in here. So I have a little resource section to where if something resonates with you or if you need something more to learn into, here you go. So learn how to become a Cisco VoIP engineer. That's, me doing a brain dump because that's what I am. So you literally, okay, let's just go over it. So you're literally looking, learning about Cisco VoIP, right? Voice over IP. We also have blockchain 101, the basics. So we had a blockchain webinar. Anybody who is in this computer science bootcamp get all of this information at no extra charge. So as we continue adding in more courses, you guys are already here. You get the new updated courses. Okay. So we literally have a whole rundown of blockchain. I got this information when I went to MIT, so this is all valid. This is all good information to get you becoming a blockchain engineer or really just knowing what blockchain, the basis. It's really good information. I'd say if you like it, please get into it. We have non-tech related books. I've read about 80% of these books. I'm trying to at least get them hard copy. Well, most of them get everything hard copy because, I'm just not on the PDF phase anymore. I got a little money, so I want to, get all the books that I've read. These are really great mindset books. I went to a Toastmasters before, and they were just, bragging about Rich Dad, Poor Dad and Think and Grow Rich, and how that really just helped them with, cause I don't know if you know Toastmasters. Toastmasters like, speaking engagements where you learn how to be a speaker and such. So, they're really like, these are really good books. On top of that, I was a part of a Forex group, we all got it, swindled into them MLMs. So I was part of a Forex group, but they were like, you have to read books on mindset because that's the only way you're going to really be good at trading, good at Forex, which, looking at it back, it's so true, trading, I do a little option trading, a little crypto trading. And, it really is mindset. Like, I can't tell you this enough. But this is other stuff. Maybe you want to be a seller. You want to learn how to sell. You're a sales engineer or something. Or you're learning, maybe whatever. I don't know. But these are really, really good books to help you with your perspective. No lie. You'll probably go to any coach or mentor, life coach out here. Trust and believe they're going to have at least 50% of these books to recommend to you. So no lie, these are awesome books. UI, UX learning, user interface, user experience. This is a whole hub here. Teach you exactly how to get it together. Get your portfolio together, get, job search. Listen, if you're not using these resources, I just don't know what else to tell you. CompTIA Security Plus exam guide. We got cybersecurity. From Cisco exam guide. They just came out with this. So I think you probably should hop on this to all my security folks. Products and services. We don't really need that much. Entry level, cybersecurity. So yeah, again, this is help you with your resume. This is another like design, layout. They're just a whole bunch of good information. And it's going to do nothing but grow as we continue on. All right. So that was it. Does anybody have any questions, comments? Let me see. I posted my homework on the site. Yes, there you go. There you go. I was in Notion, didn't see a homework link right away. Now it's clear those links are inside day one and each week going forward. That is correct. Yes, you have to click into the actual pages. Okay, so this is our main hub page. All the main information on this, and you have to literally click into the details that you want. But for moving forward, yes, it will be in our, at least for week one, our homework, our lessons will be here in week one. Okay. And homework and lessons, again, they're all together. I don't really want to separate it like I did last boot camp, where I had like a homework section and I had a lesson section. No, we're all going to keep it together, keep it cohesive. All right. So yeah, is that I'm currently reading Limitless. Yes, these are good books. I'm going to keep updating them because I haven't updated all of them. It's kind of time consuming to put it in here. Oh, I even have a list because I couldn't even find here. These are good books that I have on my own. Let me go here. How to Be Interesting, Deep Work Flow, The 4-Hour Work Week. Oh, that changed my life. Ego is the Enemy, How to Fail at Almost Everything and Still Win Big. Great book. The Subtle